Hello and welcome to another one of D's ADD videos. Today we're going to be looking at the concept of error approximation. You can use calculus to approximate propagated errors. What is a propagated error? Well, when you're doing errors and you have an error, say, in a base measurement like a radius or a length or width, any formula that uses these measurements will thereby inherently have an error propagated. So if there's an error in the radius, there's going to be a propagated error in the volume or in the area or in the circumference. Okay? Usually I have a d box here or d variable to indicate that this could be anything. An error is usually written in the plus or minus form. You might see a measurement that looks like this, where its radius equals 5 millimeters with a plus or minus 0.01 error on it of a millimeter. Okay? So that plus or minus would be the error. Now, you might be asked for a relative error. What is a relative error? Well, a relative error is whenever you have the derivative of whatever over the original whatever. So in this case, we might be looking for the relative error of volume. That would be dV over V. If we were looking for the relative error of the radius, it would be dr over r. Okay? So the last thing you might encounter is a percent error problem. And if you see percent error, you just take your relative error and multiply it by 100. Knowing these concepts will help your problems so much, and you will be able to work these so much easier. So make sure you check out the example videos. There's more to it than just this, but for the concept, that's all you really need to know. It's like implicit derivatives. We multiply every derivative by, instead of d something dx or related rates d something dt, here we're just going to put the dx, dl, dw. All right. So if I were to derive an x squared, that would become a 2x dx. And that would be accounting for the error in this x. Or if it was, area a dA when we derive this side. So I'll do the derivative in red. So the derivative would be dA equals 200 minus 2L dL. Okay? So each of these accounting for their respective errors. So make sure you just check out the example videos. It'll make more sense once you see it applied. This is just an introduction here. So I hope I've done my job to get you started. Thank you. Practice, 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 and have a nice day.